I'm Michael West, Technical Product Manager with VMware. I'm going to show you how to automate Tanzu Kubernetes clusters using GitOps continuous delivery. GitOps is a way to automate Kubernetes cluster management and application delivery by using Git as a single source of truth for declarative infrastructure and applications. Changes to the Git repo cause automatic changes in the deployed infrastructure. Our DevOps team has a declarative YAML specification for a Tanzu Kubernetes cluster and merges the file into their Git repository. Argo CD is a continuous delivery application deployed on the supervisor cluster within vSphere. Argo has registered a webhook with GitHub to be notified when the repo changes. Argo pulls the latest versions of the manifest from the Git repo and compares the active state of the system with the desired state defined in the manifests. In this case, the manifest defines a Tanzu Kubernetes cluster. Argo applies the manifest through the Kubernetes API within the supervisor cluster, instantiating all of the custom resources through the Tanzu Kubernetes Grid service for vSphere. Various controllers that are part of the TKG service for vSphere actuate these resources into a set of virtual machines that are configured into a Tanzu Kubernetes cluster. Okay, let's jump in and see how this works. Within vCenter, I have created a namespace called Argo CD and applied a set of deployments for the Argo CD application. They are instantiated through the vSphere pod service as a set of pods running directly on ESXi. This is my Tanzu Kubernetes cluster specification. Notice that it will deploy a cluster with 2 worker nodes. I add the file into my local repo, commit my change, and then merge it into my GitHub repo with the push command. The file is now available in GitHub. In order for Argo to orchestrate the deployment of this manifest in our environment, we must create an application. We define the GitHub repository and folder, then point it to our supervisor cluster and namespace as the deployment target. Our application is currently out of sync because the manifest in GitHub is not what is in Argo. We have configured manual sync in this part of the demo. As the synchronization occurs, we see the hierarchy of components that are being created on the supervisor cluster in support of the Tanzu Kubernetes cluster deployment. Keep in mind that it is the Tanzu Kubernetes Grid service for vSphere that is creating the cluster. Argo simply pulled the updated manifest from GitHub and submitted it to the Kubernetes API in the supervisor cluster. We use the kubectl get to see that the Tanzu Kubernetes cluster custom resource was created, and through the describe command, see that cluster nodes are in the process of being created. Tanzu Kubernetes clusters are defined through many custom resources. We see that both machine and virtual machine objects have been deployed. From the vSphere client, we can see the new Tanzu Kubernetes cluster inventory object and the VMs that make up the cluster. At this point, we updated the Argo sync model to automatic, and we'll change our cluster specification. We want to change the number of worker nodes from 2 to 3, so we update the count in our YAML file. We will add the changed file to our local repo, commit it, and then push it to GitHub. Notice that GitHub and Argo are out of sync. It takes a few seconds for Argo to get the notification of a change in the repo. It downloads the updated manifest and applies the change. The artifacts are then updated in the diagram. Let's go back to the supervisor cluster and see that the machine and virtual machine objects reflect the addition of a new worker node. And finally, we see from the vSphere client that the cluster has 3 worker nodes. Automated continuous delivery of Tanzu Kubernetes clusters on vSphere.